Now we're recording. So I appreciate that. Always check. Thank you, Myra. All right, we have two functions that meet at x equals 2. They're merged together to be one function. This is one function that consists of two functions that separate, if you will, at x equals 2. And we're going to be finding g of -8 and g of 2 and g of +8 in the light of this kind of reality, if you will. Well, over here to the left of 2, g of x is going to equal x plus 9. So I'm going to write that down. And over on the right, g of x is going to equal 8 minus x. Okay, and it's like x equals 2 is the dividing number. So over here, where g of x equals x plus 9, if I evaluate -8, then I'll have g of -8 equals x plus 9. And I'm going to skip 2 for a minute. If I come over here to 8, where g of x equals 8 minus x, I'm going to say g of 8 equals 8 minus 8, which is 0. Okay, so over here, yeah, do this the right way. G of -8 is going to equal -8 plus 9, because -8 will go in for the x, and -8 plus 9 is +1. Now, 2 itself is the number that divides these two functions. I have to look and see which of these will allow me to use 2. And this one will. This says x is less than or to the left of or equal to 2. So g of 2 is going to go into this function. So we'll put a 2 in for the x. 2 plus 9 equals 11. Okay, so those are our answers. G of -8 equals 1. G of 2 equals 11. And g of +8 equals 0. Given that you have a piecewise defined function, you have a piece over here, x plus 9, over to the left of 2, or equaling 2, and you have a piece of g of x that exists over to the right of +2. And while it looks really strange, there are functions like this that are used mostly by shipping companies like UPS and the United States Postal Service, where you pay a different rate by weight, and it goes on up. Okay, I'm going to save this. And now we're going to go to one that's a little more complicated. this right here, and I wish I had put my number line up higher, but oh well. Here we have a function that's divided into 3 pieces. Negative 5x minus 20, which is over on the left of x equals negative 3. 4, so you'll have y equals 4, which is between x equals negative 3 and x equals 4. And then you'll have a piece of h of x, which is the function x plus 3, over here to the right of 4. And then there's also, we have to pay attention to where x is going to actually equal negative 3 and where x is actually going to equal 4. So let us see, I'm going to put this down here. And okay, if I go to x equals negative 3, and then x equals 4, I call those the change points. And I'm actually going to draw these a little higher. So that I can do this. Over here to the left of negative 3, h of x equals negative 5x minus 20. And between negative 3 and 4, h of x equals 4. And we talked about this a little bit in the past. This is just the line y equals 4. So if you were graphing a line, it would be a horizontal line. No matter what y is, x has to be, well, yeah, y is always going to be 4, no matter which of these x's we encounter between negative 3 and 4. Y will always be 4. That means h of x will always be 4. That makes it really easy. Over here to the right of 4, and you have an arrow pointing to the right, you're going to have h of x equaling x plus 3. Okay, so let me save that. Okay. So we're being asked negative 8. If x equals negative 8, what is h of x? If x equals 1, what is h of x? What is h of 1? If x equals 4, what is h of 4? And if x equals 9, what is h of 9? So I'm going to put red dots on those numbers, negative 8, 1, 4, and 9. Negative 8, 1, 4, oops, I should have done that in blue. So let's do it again. Negative 8, 1, 4, and 9. Okay. Well, for negative 8, I use this piece of the function. H of negative 8 is going to equal negative 5 times negative 8 minus 20. And in here, h of 1, h of 1 is just going to equal 4. No matter what x is, y equals 4. I'm going to skip that for a minute, and I'm going to go over here to x equals 9, and I'll put that into x with this piece of the function, h of 9 equals 9 plus 3. All right, let's see what that is. 9 plus 3 is 12. And over here, this h of negative 8 is going to equal negative 5 times negative 8 is positive 40 minus 20, that equals 20. Now I have to figure out where I can use x equals 4. So I come up here and I see, okay, x is allowed to equal 4 for this piece of h of x. Okay, so I'm even going to draw a line here, an arrow, and say h of 4 equals 4 plus 3 equals 7. So now we know h of negative 8 equals 20, h of 1 equals 4, h of 4 equals 7, and h of 9 equals 12. And that's how you do piecewise defined functions. Now we're going to move on a little bit. We're going to actually graph them. So let's see, I am going to have 2 lines. I think I'll make them 2 different colors. But first, I need to look at the x's where the separation, where the pieces, where h of x breaks apart into pieces. That's 7. So I'm going to draw a red line up and down at x equals 7. Let's see, wait a minute here. Okay, that's 8, that's 7. That's where the separation occurs. Now these are both straight lines, so all I have to do is find 2 points for each one, but there's a catch. Wait and see. Let's see, so I might as well make that green. I'm going to make that green. Okay, so if I have y equals negative 3/7 x plus 2, I'm going to make an x and a y table to come up with 2 points. Ooh, wiggle, wiggle. Okay, now I have to let x equal 7, even though it says here that x can't actually equal 7. This is more like, well, if it could equal 7, what would that be? And then I can choose any point over to the left of 7. So let's find a good point. How about 0? X equals 0. That's always easy. When you can use it. You can't always use it, but here you can. Okay, now y is going to equal negative 3/7 times 7. And I might as well write 7 as 7 over 1 when I'm having to multiply a fraction anyway. Plus 2, I don't want to forget that. The 7's cancel. When you're multiplying fractions, the number down here and the number up there, if they're the same, will cancel each other. And so I'll be left with negative 3, because there's just a 1 here. That would be negative 3 over 1, which is negative 3, plus 2 is going to be negative 1. Meanwhile, if x is 0, then I'll have negative 3/7 times 0 plus 2. And any number times 0 is 0. So that means if x is 0, y is 2. Now at negative 7, x is going to equal negative 1. But x can't equal 7. So y is going to equal negative 1. But x cannot equal 7, so that's where I put an open circle. Right here. Then at x equals 0, y equals 2, there's no problem with that. So now I'm going to draw, graph, a line through what would be x equals 7 and through x equals 2, which is, well, x equals 0, which is y equals 2. And there you go. Okay, if x is 7, if it could be, y would equal negative 1. And if x were 0, if it is 0, then x can equal 2 with no problem. And so I draw my line, and there it is. Now, if x equals 7 or all the numbers to the right of 7, y is always going to equal negative 1. And notice that here x can actually equal 7. So this gives us a kind of a complicated situation, because for x equals 7, y is going to be negative 1. So this hole is actually going to be filled in with blue. And then for all of the numbers to the right of 7, y will always also be negative 1. So that is the wacky, wild way your lines are going to look for this piecewise defined function. And notice that since most of these graphs are just in black, you would never have known If you were just walking in off the street and you looked at this graph, you would never know that one line had been an open circle and the other line had come in and filled it up. All because of which piece of f of x is allowed to equal which piece is allowed to actually equal x, and what y equals when x does equal x. What y equals, yes, when x does equal x. How are we doing in there? Out there?
I just have one question.
Sure.
So the line is when x is 7, right?
Which problem are you on? This one?
Yes.
Okay.
So when x equals 7, it's just that vertical red line.
No, the vertical red line is not really there.
Okay.
Let me get rid of it. I just put it there to symbolize where the separation occurs.
Oh, okay.
I can even erase it now. There. That's what it would really look like. Does that help?
Yes.
Okay. Anybody else? Okay. Well then, let us move along. Let me save again. And from now on, I'll erase the red lines when I'm done with them, because they're not really there. You've got 2 points where f of x breaks apart into 3 different pieces. You've got x equals 0 and x equals 3. And my very wet cat just jumped in my lap. How nice. This is, let me introduce him. This is George. Okay, that's George. So 0 and 3 are where separations are going to occur. So temporarily, I'm going to put red lines through those x values. Just to remind me that I'll have special stuff going on there. And then I'll erase them afterwards. Okay, now I'm going to, let's see, I have to decide on my colors. I'm going to keep 1/4 x plus 3 black. I'm going to let 4, well, no. I'm going to let 4 be green. And I'm going to let negative x, negative x, be blue. This is just to remind me, just me. Okay. We're looking at this function. In fact, I'm even going to write it. F of x is going to equal 1/4 x plus 3 over here to the left of x equals 0. f of x, and I'm writing it up here for a reason, f of x is going to equal 4, and what that means is y equals 4. A lot of noise outside today. Y equals 4 between 0 and 3. X equals 0, x equals 3. And then to the right of 3, f of x. My cat just looked at me while I was talking like, what are you saying? -4. Okay. So now, let's get to work. I need to find 2 points that will let me draw this line. So we are going to have, for sure, I have to let x equal 0, and I'll even have a solid point there. So f of 0 is going to equal 1/4 times 0 plus 3, which will be 3. So if x is 0, then since x is allowed to equal 0 up here, I'll put a solid hole at 3. Okay. Now I can choose any x value to the left of that. How about, I don't know, how about -4? F of -4 equals 1/4 times -4 plus 3. Yes?
In this part of the formula, can we choose any number?
Yes, you can. The thing is that I decided to use a multiple of 4 so that I could cancel out that 4 and get rid of the fraction. So it would be easier. And that would happen also if you use -8, because 4 goes into 8 2 times. Okay, so this is why. 1/4 times -4, 4 goes into 4 one time, so I'll have 1 times -1. Meanwhile, there's this plus 3 out here. So I'll have -1 plus 3, which is 2. So I just did that because I was lazy. I admit it. So here at x equals -4, y is going to equal 2. And so I will draw a line, and I don't have an already made black line. I need to fix that. So I'm going to have to draw it with my particularly wavy lines right there. And that's more or less what f of x equals 1/4 x. I didn't need to put that. 1/4 x plus 3. I think George needs to move because I can't concentrate. And now I have to wash my shirt. Blech. All right. Now for y equals 4. Notice that x cannot equal 0 and x cannot equal 3. So, but for any other x's between 0 and 3, y is going to equal 4. Therefore, this is what I will have. No, get down. I'm going to have 4. So I'm going to do this in green. I'll have a circle here and a circle here and a line, because for all the values of x between 0 and 3, x can actually equal those x's, so I have a solid line between x equals 0 for this part. X can't actually equal 0. There's x equals 0 down there. So y will have to be an open circle there. And for the same reason that x isn't equaling, he's back. All right, just be good. Yeah. All right, yeah, that's why we have circles at the end there. Now, let's check out f of x. It's not -4, it's negative x, which is very different. And I was going to make that in blue, so I should have written it f of x equals negative x, and I should have written this in green. F of x equals 4. Okay, now f of x equals negative x over here. So we're going to get 2 points here. If, let's see, if x, no, blue first. If x equals 3, then f of negative 3 is going to be negative x. No, positive. I want it to be positive 3. F of x is going to equal negative 3. Yeah, that's positive 3. So positive 3. Then that's what we'll have. And I might as well choose another point while I'm here. Any point, we could choose any point. How about x equals 5, as long as it's to the right of 3? Right, because we have f of x equals negative x. Whatever I put in here, I put in for the x, but there's a negative sign in front of it first. So at x equals 3, which is right here, y will equal negative 3, and x can actually equal 3. So I can make it a solid whole. And if x equals 5, y is going to equal negative 5. Negative 4, negative 5. And so I draw a line connecting up those 2 points. And we're done. So in green, this is f of x equals 4 or y equals 4, same thing. And over here, this is f of x equals negative x. And I'll even make a bigger hole here, there. Now notice that for the overall function, even though there's a hole here, an empty hole, there's a filled hole here. So x actually does equal 3 somewhere. And the same thing here. This is a solid hole. I mean, what else do you call it? A solid dot. This is an empty dot, but x does equal 0 somewhere in this function. So there aren't any breaks at all. And what you'd find if they would ask, they don't ask this, but if they asked, they being the writers of the problem, if they were to say, what is the domain of f of x? Since every x does eventually get filled in, the domain would be negative infinity to positive infinity, because these two lines go on forever. Forever to the left, forever to the right. And I'm going to get rid of the red lines that I put in there temporarily. So this is what you would actually have here. There are no gaps at all in the x's, but there certainly are in the y's, aren't there? So let's take a moment and talk about the range. The range here, all of the x's are filled in. So you have a domain that has no breaks in it, but you definitely have breaks going on in your range. Here we have negative infinity down here. This goes all the way down to negative infinity, and then this part of the graph comes to a crashing halt at y equals negative 3. So if we were just describing the range of that arm, of this piece, the range of this piece would be from negative infinity, because we always start at the lowest point, and then we go up to the highest point. And for this piece, the highest point is negative 3. And a bracket. And then if I were to keep going up, up, until I got a signal, whoop, there's a part of the graph here, there's a part of the graph here. I'd come over here and I would see, oh, look at this arm. This arm goes forever to the left, but also it's tilting down, so it's going to go forever down, and then come to a crashing halt at y equals 3. And then there's no more of this graph. So the range of this part would be from negative infinity down here all the way up to y equals 3, where we have a solid dot, so I would put a bracket. And then I would keep going up until I find another part of the graph. And I would say, oh, my goodness, or something. This is very interesting. Because look at this, y does equal 4 in here, but it never gets above 4. It never gets below 4, not this part of the graph. So this range is one of those unusual ranges you get when you've got a one value range. The range here, no, let's do blue, green. The range here is only the number 4 on the y-axis, and what we do when we have just one number like that is we put braces around it. So what that means is the set that only holds 4. Or think of it as an infinitely large box. A box that only holds the number 4. It's like if your little sister is going to be 4 years old, you're so mean, you go to Walmart, you get a number 4 that goes on a cake, you put that 4 in a box and that's all you give her for her birthday. Just a box that holds the number 4. That's it. That's what those braces mean. Watch, one of you will do it. How mean! So now how would we write this? Oh, goodness. I'm glad I don't have to figure it out. But remember that this is eventually going to be at all of the y coordinates that this one is at, because this keeps going down forever. So in a way, this arm is going to be completely covered by the y values that this arm goes through. So yeah, it took me a minute there. The range for the overall function, which is f of x. The range of f of x. Okay, is negative infinity to 3, unioned up with the set that holds the number 4 and nothing else. Sometimes these things get really weird. And that, if we were only looking at y values, if we were looking at a computer that only sees y values, that would be the range of this function. Yes, it would. This is not asking you that. However, the last problem, which is right here, does ask you for the domain and range. And so since I don't expect we'll have time to get to this problem, I thought, oh, well, we're about to, aren't we? Doggone. Okay. Yeah, that would be the domain and range of this problem. And I somehow didn't realize we were already at the end. This is the last problem. Really? Yeah. Okay. Well, all right, we're going to do this. We have a function that separates at 0, so we only have one value. This isn't like this, where there's x equals 0 and x equals 3, where you have a separation. Are you getting down? No, you're just getting comfortable. Okay. Now for this piece of f of x is to the left of 0, but it cannot equal 0. So we're going to have an open hole there. And then on the right of 0, x can equal 0. So this will be, there will be a solid hole there. Okay. And since x equals 0 already has a darkened circle there, I think I won't make a red line. Instead, let's let this be green. And this be blue. And that's just for me. It's not something, excuse me, it's not something you have to do. It just makes it easier, I think. Okay, so we're going to find f of x equals 1/2 x. All right, and x is not allowed to equal 0, but if x could equal 0, there you go. What is 1/2 times 0? It's 0, right? So at the center, the very center, which is automatically colored in, doggone it, we're going to make an open circle. Maybe I should have put a red line, but oh well. Now, for any number to the left of 0, I can choose any number I want. Why not choose a multiple of 2 so I can cancel out the 1/2 fraction? I could choose 2, -2, -4, -6, or -8, or -10, and cancel out that 2. So I'm going to choose -4 this time. If x equals -4, then f of -4 is going to be 1/2 times -4, which is 1/2 times -4 over 1. Okay, 2 goes into 2 one time, and 2 goes into 4 2 times, or you could say 2 goes into -4 -2 times. Then, if you multiply the tops and the bottoms together, I'm just doing it the long way right now, -2 over 1, which is -2. So, if x is -4, y is going to equal -2. And that would put a nice filled in dot right there. And then I can draw a line. There. And that would be f of x equals 1/2 x. Now, we're going to look at f of x equals x plus 1. And the first x equals 0 we're going to use is f of 0. Okay, so when x is 0, y is 1. So here's x equals 0, here's y equals 1. We'll have a solid hole there. And then I can choose any number I want to the right. I could choose 1,000,000 if I wanted to, but might have trouble graphing it. So I would say, what would happen if I would choose x equals 4? So x equals 4. That means I put a 4 in here, which means it goes in for x out here. 4 plus 1 equals 5. So if x is 4, y is 5. And then I draw my line. Okay, I have to save those right away. All right, there's my graph. Now I have to look at this graph and find the domain and the range. The only break that occurs in the graph is here. But notice that while x equals 0 is an open circle here because x cannot equal 0, it's filled in here. So x gets filled in, and there aren't any further breaks over here, or we would have been told. And there are no further breaks over here, or we would have been told. So the domain is going to go from negative infinity on the left to positive infinity on the right. So domain is okay. There are no breaks in the domain. We will be dealing with breaks in the domain fairly soon. But the range. Coming from the bottom, and so we can see it. Remember that down here, we have negative infinity, way down. This arm of the function is going to keep going down, so eventually it's going to go to wherever negative infinity might be. I'm not sure. I want to find out. And then it keeps rising, 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 and it comes to a stop at y equals 0, which is on the x-axis, because of that open hole. So it stops, actually, the left arm stops at y equals 0, but it doesn't actually equal y equals 0. So I put a parenthesis. Yeah, my drawing. There's no need to be a perfectionist. There really is not. It's a character defect. Okay, now I'm switching to blue. Well, no, I don't have to switch to blue. Now look, there's an actual gap on the y-axis here. where no y coordinates are used. And then the y coordinates pick up at, you're actually at y equals 1. Y actually equals 1 right here. And then it keeps going up in an unbroken fashion forever and ever and ever and ever, all the way to positive infinity. So on the other side of it, we're going to, oh no. On the other side, we're going to pick up with a bracket because y actually equals 1 there. Y actually equals 1 because x can actually equal 0. And then it goes up forever. And you can never use a bracket around an infinity sign, no matter what.
Would you
Now,
not put the sign in?
That's right. You always stick intervals like this together. You don't use a plus sign. You use a U sign. U is called the union sign. Nothing to do with the American Civil War. The union sign, because it sticks two things together. It sticks two separate things together. Here, there's a break in the middle. Whenever you've got a break in the middle of your domain or your range, if there are, for instance, in your domain, if there actually are x's that are not filled in, you're going to end up having to use a U between two intervals. And or more than two. In the range, there actually were here some y's that are just not used. So you've got a gap. When you've got a gap like that, you use a U. And you'll have plenty of opportunity to use U's. So that's the domain, and this is the range. And I'm going to hit save. And now I'm going to ask for questions. Any questions? Then maybe I'll be nicer than I was yesterday and say, okay, we're not going to venture forth into an entirely new set of problems. Instead, we're just going to stop here. And you can go if you want, or you can hang around and ask questions. So bye-bye if you want to go. Oh, don't go. Don't go. Wait, wait. There. Now you can go if you want to. Bye-bye. It's okay. I'm here for Alexa.
Yes.
Talk to me. What kind of questions?
I was just gonna say have a nice day.
I'm sorry, I didn't understand. The microphones are kind of sketchy.
I was just going to say have a nice day.
Oh, thank you very much. You too. Stay dry. Anybody have some questions about what we did? I am glad to talk about it. I don't hear anybody, so I am going to assume you don't have any questions.
Miss Rademacher, I was gonna see if you have availability today. I don't know if you have something around like 3 or 6 or around that time.
I actually have my usual office hours around 3, so just come to my usual office hours.
Okay, cool. Can I give you a call through Microsoft Teams? I'm having a little bit of difficulty understanding these part of the problems.
Yes, they're hard. They're harder, and they'll just keep getting harder.
Yeah, I figured I would just try one-on-one to see if I can get the hang of it, because I'm a little confused.
I can't promise you one-on-one at 3
Okay.
because those are my set office hours, but almost nobody ever comes.
Oh
Yeah, so probably it'll be one-on-one anyway.
no.
But
Okay.
if not, I'll just bounce back and forth. All of my students are either college algebra students or intermediate algebra students, and then you guys are both.
Gotcha.
So one way or another, everybody's questions would be related to everybody else if there are people there.
Okay, cool.
So I'll see you then.
Alrighty, what's a good time? Do you want me to meet at 3:15? What's a good time?
Well, three is just as good at 3:15. I'll be there from 3 to 6.
3 to 6? Okay, let me write that down. Alrighty,
Okay.
I'll go ahead and give you a call then, okay?
Okay, on Microsoft, on Teams?
Yes.
Okay, sounds good. Do that.
Okay, bye, Miss Barbara.
Bye. How about you, Mitchell or Tran? Any questions? Well, Tran, let me talk to you for a minute. On your student, on the official roll, it has your name spelled T-R-A-M rather than T-R-A-N. So you might want to check on that. That's all I have to say. It's not a big deal. Unless you want your name spelled right. Then it would be a big deal. Okay, I will see everybody later.